This is Andy Schaefer's application engineer at Acuity. Today I have a video tutorial on NX-CAM adaptive machining. I'm using NX version 1880, and this tutorial is specifically directed at our current users of NX-CAM who have in the past used the trochoidal milling strategy for roughing out their parts. Although trochoidal is available in cavity mill, I'm more interested today in the applications for trochoidal that were available in planar mill and showing users how they can duplicate that same type of functionality using adaptive machining. First, we'll look at an example of trochoidal machining in planar mill as applied to the part you see here on the screen. I have two operations here. In the first one, we see that the part boundaries are defined as closed shapes around the two ears, and then the blank boundary is also, of course, closed, and it's in between. Here I'll show just one of the levels, but it's a pretty straightforward application where the trochoidal cuts go through on one side, and then a more conventional type machining goes through on the other. This particular operation is also using the finish pass option, where we're leaving 5% of the tool diameter as finish stock. Now, our adaptive machining operation does not have that finish pass option, so we'll be creating a second operation to do that with. Now let's look at the second operation that's shown here. We will be rotating the machine 90 degrees, and here again we see a closed shape for our part boundary, and then here is the stock boundary, so that's been manually created. And that's one of the big differences in the adaptive machining workflow, is there is not a blank boundary that can be created within adaptive milling. We will be using the IPW or in-process workpiece to do that job for us automatically. So before we start creating our operations, we'll need to check our geometry setup and make sure that it's compatible with the IPW function that we're looking for. So we'll return here to the geometry view, and we see that we have a workpiece at the top level, and that's been defined as the part, and then here is the blank. Underneath that is the coordinate system, and then our operations will go below that. There are actually many different geometry setups that will work. What's important is that each operation that we create needs to be a child of a single blank. And this particular setup does meet that requirement, so it's our expectation that this is going to work correctly with adaptive machining. So let's get started. Adaptive machining is in the mill contour area if you're using the out-of-the-box setup for your templates. I'm going to start with this 1/4 inch end mill, and of course, as we already discussed, we'll be using G54, the coordinate system, as our geometry start point. Here's the dialog box for adaptive milling. So that we can learn more about the process, I'm going to give the operation minimal inputs. We'll hit generate, look at the results, and as we see problems, we'll solve them one at a time and then regenerate. I do want to make sure that the tool axis is correct. If I turn my MCS on, I've got Z going in this direction, and for the cut we want to make here from the top, that's correct, so we don't need to reset our tool axis. Let's just go ahead and generate then and see what result we get with the default values. Obviously it's cutting around the outside. That's not what we wanted. We wanted to focus on the inside, and we see that it's cutting way too far down. And a third problem is it looks like we're cutting too deep with each pass. We wanted 4 passes in here, not 3. So let's first fix that cut level. That seems to be the easiest thing for us to straighten out. And here on our range definition, I'll select this face. That's as deep as we want to go. So that immediately straightens out quite a few things. Let's hit generate. And that's looking better. However, we did want 4 passes there, not 3. Let's change our maximum distance here to 80. This is the percent of the flute length is what we're measuring in this case. Okay, that's much better, but again, we are machining all the way around the part and out here on these corners, and that's not what we wanted to do. The way we need to control that is with a trim boundary. Now, I don't actually have a sketch to do that yet, so I'm going to click OK, dismiss the dialog box, and we're going to create this sketch. I'd like to put the sketch right on the end of this cylindrical face here. So I'll select that. Now I need a horizontal orientation and finally a point to be the center of my sketch. Okay. Now in this case I'm going to draw a rectangle, and I'm going to do it incorrectly. I'm going to make a rectangle that's too small for the tool to actually engage out off the side of the part. And what's going to happen is adaptive machining will see that in the trim boundary and then force a helical gauge in the middle, which of course is not what we want. So we've created the sketch. We just need to return to the adaptive milling operation and then assign that sketch as a trim boundary. I do need to be careful here. I want to trim the outside, not the inside. And we'll generate. Here we see that the sketch, the trim boundary, is successful in preventing the tool from creating the peripheral geometry like it was before. But we do see this problem where we now have helical engages coming right down in the middle of the part. That's going to be very inefficient for this job. So again, let's depart from the operation, and I want to go back and edit the sketch. I just need to stretch this rectangle out. The exact size is not important. I just want to make sure I have room for that tool to sit down out here off the side so that we get an open profile engage. The operation's out of date and I just need to regenerate. Okay, that's looking much better. I'm having my engages come down off the side of the part and there is no helical motion in Z. There's just a couple more things to fix. Remember I mentioned that there's no finish pass here in this operation type. What this means then is that I'll go into cutting parameters and I've got to add some stock, or make sure the stock is there. And in fact, I've already had that set. It's at 10 thousandths. So that stock will be present on the part. I just need to create a finish pass so that I've got a similar function to what we had previously with planar mill and the trochoidal. Before we create that finish pass, let's double check to make sure that we do have an in-process workpiece for our adaptive milling. I'll go back to the program view here. And I see we do not have an IPW. So let's run back to the operation, verify 3D dynamic, and here I'll just suppress the animation. The IPW is set to save, and I'll hit the fast forward button. And there's my IPW. Now when I look at the operation navigator here in the IPW column, I see that I do have an IPW generated. So I'm ready to move on to my finish milling operation. I'll choose to do this finish pass with the floor wall IPW command. As we enter the command, we see our IPW shown transparently against our part geometry. I'll select this bottom face as our cut area floor, and as I do so, immediately then we see a preview which looks good on the inside, but I see these little triangles where it's going to try and cut these chamfers. Let's solve that problem now. I'll go into cutting parameters, containment, and here instead of extending the floor to the blank outline, we'll just extend to the part outline, and those are removed pretty much immediately. Again, we're going to work in the mode where we're just kind of sort of fixing one thing at a time, so it's easier to see the effects of the different parameters. I'll switch here to profile, and let's generate again, looking at our result, and we're shanking out the tool. It's warning us about our flute length, which is 0.375. So let's change the depth of cut to 0.3 and see if we get a better result. And we do not. We get the same result with a different error message, and what it's telling us is there's so little stock on the side that the tool overhang as it's currently set isn't going to allow anything to be machined. But upon closer inspection, we see maybe we've got another problem here. Although these triangles show up in our preview, it's not actually machining them. Now it turns out that both of these problems have the same solution. We'll go back to cutting parameters again, and in containment then we would like to change our tool overhang here from 50% out to 100. And so instead of just bending around that corner, let's roll around that corner. So we'll just choose roll around, click OK, and one more generate. That looks like what we're after there for our finish pass. Let's create our second adaptive machining operation now. We'll be coming from the other direction, and we'll be using a smaller tool. Here's our 1/8 inch tool. And I know that I'm going to need to straighten out the tool axis this time. Now I have a sketch already created, so I'm going to turn that on. And this we'll use again for our trim boundary. Of course, changing the side trim to outside. And once again, let's just generate and look at our result. Well, that certainly is machining the area we wanted to, but it's also remachining the inside, which is already gone at this point. To understand what went wrong here, we need to go back and look at containment. Clearly, the trim boundary is the only thing that's preventing our tool from probably machining the entire part here. So we'll go to cutting parameters, containment, and we can see that by default this command is not using the in-process workpiece. So we need to choose use 3D. That's really the other part of the equation. In the first adaptive machining operation, we created an IPW, and now in this second operation we need to tell it to use that containment. So we're hoping to solve two problems. We would like to machine only back into these roots, and we want to get rid of this helical engage. We want it to understand that there's open space here that it can drop the tool into. So let's generate. And that looks successful. It's using 95% of our flute length. That's causing it to make 3 passes on the way down. And our engages are not helical, and they're off here in the open space. Our trim boundary did prevent the tool, though, from getting into the stock that's on the side, which it otherwise would have seen. Let's look at one further alteration we might make to our program. It's common to use reground cutters for hard materials, and we might want to turn cutter comp on so that the operator at the machine could quickly change the diameter of the cut. So here we'll go to our start of path, and I'm going to look for the cutter compensation UDE. Then my mode is to turn that on, and I'll take the defaults here of on before each engage and off before each retract. That's really all that's required. When I post-process this now with that start of path event, I will get G41s and G40s as part of that toolpath. Okay, that then is an overview of comparison between trochoidal milling in planar mill and our new adaptive machining technology. Thank you for watching this tutorial.